So we have to prove that the that every subgroup of a cyclic group is cyclic. So we let G to be a cyclic group generated by A. That's G equals to A, and K to be the least positive integer such that A raised to power K is also in H. This simply means that when we have A raised to power K in H, K can be any positive number. Let's say we have A1, A2, A3, A raised to power 4, 5, and all that. And we have G. Since G is the generator of all the set, this simply means that A raised to power K can also be in H. And for A raised to power K to be in H, this implies that H is a subset of G. And for it to be a subset, it must also be a subgroup of G. Do you understand? Now, we also let B to be a member of H. That this implies that, and make B to be A raised to power of M. Now, if we recall the subgroup test, we must prove for an identity and we must prove for an inverse, and M equals to QK plus R is representing a division algorithm. Now, if M equals to QK is representing a division algorithm, what we are after is not Q, but what we are after is what is M and K, because A raised to power K is in H and B equals to A raised to power of M. So that's what we are after. So when we make R the subject of a formula, we have A raised to power R equals to A raised to power M minus QK. So proving for the inverse of a subgroup test, for every A be in H, AB inverse must also be in H, right? So we have A raised to power R to be A raised to power M times AK minus Q. So we have successfully represented A raised to power R to be in form of what? Of an inverse. So that's the proof.